And we can now turn to my anthropological colleague, Dietrich Stout, who is an associate professor at Emory University and the associate director of Emory's Center for Mind, Brain, and Culture. And Dietrich is going to talk to us about the evolution of human technology and the very interesting approaches that he is taking to that important topic. Dietrich.
Yeah, so thanks very much for the opportunity to speak today. As Rob mentioned, I'm a Paleolithic archaeologist, and I'm interested in the role of technology in the evolution of the human mind, brain, and culture. So this opportunity to speak to a SETI crowd is a refreshing departure for me. In case I do happen to say anything of interest to you today, much of this talk is based on a review article that I recently wrote for Trends in Cognitive Science. So as I understand it, my role today is to comment on this part of the famous Drake equation, that is the likelihood of extraterrestrial life developing technologies that we might actually detect. And I'll say right away that, of course, I basically have no idea what the value of this variable is, but I can work through some of the considerations. And I think the main one that I'll talk about today is whether the emergence of technology should be thought of as kind of a single threshold event, or whether things are more complicated than that. And, unfortunately, I'm inclined towards the latter messy interpretation, but we'll see what you think. I'll also say that I'm glad I wasn't asked to talk about the probability of intelligent life developing, because I'm not even quite sure what that is. I am interested in the evolution of human intelligence, and I know from that work that it's pretty hard, even among closely related species on Earth, to define and measure intelligence as some kind of general property that you can generalize across species. So no dolphins were harmed in the making of this slide, by the way. So fortunately, I'm talking about technology, and we all know what technology is, right? So here are some examples of animal tool use. Would you consider these to be technologies? Ethologists will argue over the definition of what a tool is, let alone technology. So for our purposes, let's just say that not even a million of these grub fishing birds going at it would make a technological signature that was visible from space. So clearly, at least for today, we're interested in something different from simple tool use and something that's distinctly human, at least on our planet. But it's still not simple. Everyone can agree that things like rockets and computers are examples of technology. But what about things like bodily techniques, martial arts, sophisticated meditative practices, social engineering? Are these things technologies? Are they arts, sciences? What's the difference? Why do we care? Technology by different authors and different disciplines has been defined as everything from a set of hardware to a system of abstract rules for problem solving. For example, language and number systems have been described as cognitive technologies. B.F. Skinner envisioned a technology of behavior, and Foucault enumerated various technologies, including technologies of production, sign systems, social control, and something he called the self. So potential meanings of technology thus range from the smartphone in your pocket to virtually all of culture and cognition. So we need to constrain this a little bit. So here is a conventional social science definition of technology. Technology is an integrated system of hardware, people, skills, knowledge, social relations, and institutions applied to practical tasks. I think that this does capture a lot of what is interesting and distinctive about human technology, but it still leaves this critical question of what constitutes a practical task undefined, essentially asking us to make a subjective and value-laden judgment about what qualifies. So for current purposes, I'd like to make this definition more precise by grounding it in evolutionary theory, and particularly the way in which technology and biology have co-evolved to shape human minds, bodies, and environments, ultimately in ways that might be detectable over interstellar distances. So modern humans inhabit a technological niche that we ourselves have constructed. So think of this, take this scene from the Shibuya crossing in Tokyo. Arguably, there's not a single natural thing in sight. Even the bodies of the people in this picture have been transformed by our long history of reliance on technology. From reduction of the jaws and teeth and guts through external processing of food to our manipulative hands and arms, and of course, our large energy-hungry brains. But the other thing to notice in this picture is how many people there are. Human children, despite our big fancy brains, who take longer to mature and much more parental support than any other ape. And yet, despite this, there are 7 billion of us and precious few of the other apes around today. And paradoxically, human women have the shortest interbirth interval and highest total fertility of all of the apes. Now, simply put, human mothers should not be able to afford this rate of reproduction. And the reason that they can is because they receive support from others. Fathers, grandparents, siblings, other members of the community, and so on, in what has been described as a human biocultural reproductive strategy. For this to be possible, of course, the others must be producing more than the bare minimum needed to support themselves. Right? So this basically does not happen in chimpanzees. And over the life course, chimpanzee production and consumption pretty much track each other. So there's not very much surplus here for sharing. Humans, on the other hand, as you may know, have a very long and costly childhood in which they consume way more than they produce. But eventually we do catch up and learn to produce a real surplus. This surplus production is enabled by culturally accumulated knowledge and skills for material production. In other words, what I'm going to be talking about today, which is technology, right? So this set of relations can lead to a powerful biocultural feedback cycle where technology increases production, which enables sharing, which supports extended development, long lifespans, and population growth, which in turn allows for a large brain and heavy learning investments, which enable further technological elaboration and so on. So this feedback cycle has produced a human-constructed technological niche populated with increasingly complex systems for material production. So this evolutionary grounding then finally allows us to be a bit more specific about what we mean by practical tasks. And I would specify that technological systems are practical in the very concrete sense that they support the material production that underwrites at least our species' entire biocultural reproductive strategy. This evolutionary framing allows us to focus on key features of technological systems, including the fact that they are socially reproduced, deeply collaborative, and they are concerned with material goals that involve the manipulation and modification of objects to enact changes in the physical environment. So the key distinction that I'm making here is between the material instrumental goals of technology and tasks that are intended to achieve physical changes, and communicative tasks that seek to alter the thoughts, behaviors, or experiences of the self and others. So human culture clearly encompasses both, but technology is being defined by its focus on the material production in particular. So in this sense, there could be technologies for the production of communications tools, such as books, musical instruments, or computer networks, but there would be no technologies for effective storytelling, musical composition, rhetoric, or social messaging. Systematic approaches in communicative domains might be termed arts or sciences rather than technologies. So this is important. I'm belaboring this point because material and communicative goals tend to have different functional demands and design constraints. Material goals are shaped by physical situations and materials, which may be relatively invariant across time and space. Communicative goals, on the other hand, must address human or other psychology in the context of specific cultural systems of meaning. They will thus tend to implicate different cognitive processes, learning strategies, and cultural evolutionary dynamics. So with this sort of conceptual framework in place, we're finally in a position to ask the core question, which is, what is it that actually makes human technology possible? So we could argue about whether non-human tool use qualifies as technology, but clearly there is a massive difference in magnitude between the termiting wand shown here and the cell phone that's being depicted on, and this requires explanation. Right, so currently the most popular explanation is that human technology is made possible by our uniquely evolved capacity to learn from each other. In other words, that culture is the secret of our success. High fidelity social transmission is supposed to drive a lossless ratchet effect so that each generation can add to the products of the last until eventually we have very complex technologies that are vastly beyond any one individual's creative ability and that we may not even understand. And this has been enabled by the fact that our social or cultural transmission is so accurate, of such high fidelity, that we don't lose things even when we don't understand how they work. We just copy each other, and it allows us to accumulate this complexity. So this compelling concept of human cumulative culture is illustrated by a thought experiment known as the island test. So imagine if you grew up alone on an island, what would you be able to reinvent on your own in a single lifetime? Probably most of us could manage some chimpanzee tools like a termiting stick, but not something like a cell phone, which requires generations of accumulated knowledge. So on this view, the high fidelity social learning is the key difference that makes human technology possible. So in this framework, if we assume that psychological mechanisms that enable this high fidelity social learning are costly to evolve and grow, this also explains why cumulative technological culture is rare. So basically, it's supposed to be hard to get it started. According to this argument, accumulation must begin with simple skills that are invented by individuals, right? Because we don't have the accumulation going yet. But insofar as the benefits of learning these skills socially are relatively small, the social learning is supposed to make learning cheaper. I just copy you. But if this is something I can easily figure out on my own anyway, then there's not much benefit to building all of this machinery in our brain that allows us to learn socially, right? And so this creates an adaptive valley that has to be crossed before the cumulative technological evolution can start to produce the complex, difficult to learn, and useful cultural content that would actually pay for these expensive social learning mechanisms in the first place and initiate a sustained biocultural feedback. So crossing this critical threshold to the entry of cumulative technological culture is often compared metaphorically to Caesar crossing the Rubicon and never looking back, right? So in this framework, we would just have to figure out the probability of crossing this one critical threshold. And from then on, technological progress would be self-sustaining, almost inevitable. There might be some fits and starts along the way, but this single powerful endogenous process of cumulative culture and biocultural feedback would sustain the process. And so we'd be focusing on just this one major event in order to figure out how likely technological civilization is. But unfortunately, as I mentioned, I don't think things are actually that simple. So let's go back to the desert island. And now let's just imagine that you have a phone on the island. And so you can copy the design of this phone, all of the information that's available from that. But let's say you can also use the phone. You can call anybody in the world, all of the world's experts in cell phone technology. You can use it to look up plans and instructions and whatever you like. So now, would you, alone on this island, be able to make another phone? No, and the answer is I still don't think so, because technological production is about a lot more than just information. It requires materials, infrastructure, social institutions, trade networks, and so on and so on and so on. So it's more complicated than that. So the point is that there's probably no one thing or one event that made technology possible in general. Humans display a wide variety of different technologies with different demands for different kinds of cognitive and motor skills, different forms of social and individual learning, different material and social infrastructure, and so on. And of course, these would have very different technological signatures. Nevertheless, I would like to suggest that there is some synthesis possible. And that we can do this by focusing on the three unifying technological characteristics that I outlined earlier: material production, social collaboration, and cultural reproduction. Right? So for example, the materiality of technology allows for the accumulation of complexity beyond what any one person could hold in their head and provides a durable medium for collaboration across time and space. Technological materials embody information and persist across generations as a new form of cultural inheritance. Durable artifacts and situations like this blacksmith's workshop are environmental resources that scaffold cognition by externalizing information representation and manipulation. This enables the evolution of complex technological goals and extended action sequences beyond the planning and memory capacity of individuals. So this critical material amplification, in turn, depends on exceptional human capacities for skilled interaction with the physical world. Cognitively, at least in humans, this interaction is supported by internal models of the world that can be used to simulate and predict action outcomes. So this allows for smooth anticipatory control and action planning. Normally, you don't notice this kind of thing, but imagine you're reaching out to pick up a tea kettle that you think is full of water, and you lift it only to discover that it's empty, and your arm just jerks up because you have the wrong internal model, the wrong expectation, and you need to revise your model. So I have no idea if this is the only way computationally, cognitively to do things, but this is the way humans seem to do it. And we are quite good at it. So this physics engine in the brain is particularly well developed in humans compared to other primates and is developed over the course of our biocultural technological evolution. Importantly, it's also thought to play a parallel role, not just in planning and executing action, but in understanding the observed actions of others that allows us to engage in imitative learning and cultural transmission. That is, this internal simulation can be used also to understand what you're observing. And so this capacity to simulate, understand, and imitate observed actions may also be important for technological collaboration. So unlike simple tool use, technology is often characterized by the coordinated action by many individuals over extended periods of time. Such collaboration is especially obvious in the specialized roles, logistical chains, equipment, and infrastructure characteristic of modern technologies, but it's critical even in much more ancient technological systems. So at a basic level, the coordination of action between individuals is thought to rely on reciprocal prediction achieved by interpersonal alignment of the internal models for anticipatory motor control that I just discussed. Such interactive synchrony, sometimes also called brain-to-brain coupling, can occur at multiple levels of abstraction, and it provides a key mechanism supporting the development of mentalizing, empathy, communication, learning, and social affiliation. And these things are in turn critical to supporting technological collaboration at larger group and institutional scales. For example, effective teamwork is facilitated by emergent group properties, including shared mental models and affective states, while behavioral and emotional alignment promotes the self-identification with social groups that motivates norm adherence and allows the assembly of larger technological systems. And then finally, there is the reproduction of technology. This is really a special case of collaboration, and it's dependent on many of the same mechanisms. Although social learning is commonly glossed as the transmission or copying of information, technological learning is often a protracted collaborative process, better described as the reproduction of skill. And the learning demands of different technologies are going to depend on the particular skills involved. For example, this is a picture from a longitudinal study of stone toolmaking skill acquisition that we conducted in my lab. we found that although there are some basic concepts or ideas to master about stone tool making, these are pretty intuitive and relatively easy to pick up. But the real challenge is to develop the internal models and perceptual motor precision to actually hit what you're aiming for with the right amount of force. This can take hundreds of hours of practice. And the role of the instructor here is more to provide the materials, the opportunities, the encouragement for practice, rather than to directly communicate information or transmit some sort of technological data. Right, so this balance, this might be different in different technologies. For example, technologies that are more dependent on conceptual and symbolic skills. But actually, it really remains to be seen whether processes of cognitive and perceptual motor skill learning are really as different as we might think they are. In any case, it's clear that the conventional distinction between social and individual learning in comparative psychology and cultural evolutionary theory is difficult to maintain in the case of technology. In fact, social and individual learning rely on pretty similar neurocognitive mechanisms, overlapping mechanisms, and are thoroughly intertwined throughout natural real-world learning processes. This is exemplified by technological apprenticeship, which alternates social learning with individual practice in a iterative process of increasing refinement. So social information ranging from artifacts, tools, and observable behavior to intentional demonstration, explicit instruction, and effective feedback from teachers guides learners to recreate increasingly sophisticated skills through deliberate practice over extended periods, with each round of individual practice allowing deeper appreciation of the available social information. Again, all of this complexity and variety means that we should probably not be looking for one simple explanation or threshold moment that set humans on an inevitable path to ever more complex cumulative technology. Rather than like this kind of process of a major evolutionary transition, we should be considering the complex and historically contingent processes by which the evolution of particular technologies can occur. In fact, we see precisely this kind of thing even in the very earliest archaeological record. So the first known stone tools occur at one site 3.3 million years ago, and then there's nothing for another 700,000 years before we start picking up a few more sites, just a handful of sites in Ethiopia. And in fact, stone tool making in general didn't really pick up and spread around Africa until about 2 million years ago. So that's, 1.3 million years from the idea to it actually catching on. So what is it with all of these fits and starts and interruptions and, slowness? So this puzzles us because archaeologists and many others have a bias to think of technological change as progress. That's something that you would always want to do if you could. But new technologies come with costs as well as benefits. There can be a lot of front-end costs in gathering raw materials, making and maintaining tools, learning how to make and use them, before any of this starts paying off. So in some circumstances, you'd be better off just diving in right away with your simpler technology or simple tools rather than choosing to adopt a more complicated approach. All right, so there are costs and benefits. Even something, this is a paper that just came out as I was preparing this talk. But even something as basic and beneficial as cooking your food, which really increases food value and palatability and all sorts of things, it doesn't always make sense if you consider trade-offs in terms of fuel and time. So, if we fiddled with some of these variables about the cost of cooking and the return rate that you get, if we change some of those variables, would our ancestors even have bothered with the controlled use of fire? If they never had started using fire to cook things, what would our technologies look like today? Food production, it's even more complicated. For one thing, farming is not always as profitable as we might imagine. It seems like, oh, of course, as soon as you have this insight that you can plant crops, everybody's going to do it. Well, no. In fact, in a lot of conditions, it actually is more work than it's worth, and you can do better by staying a forager. So adopting farming only makes sense in certain climatic and environmental conditions. And furthermore, beyond this, farming doesn't make any sense unless you get to keep the stuff that you grew, even if you can't eat it all immediately. So in fact, doesn't really seem like farming can take off unless you also have a social institution of private property. And if you do develop that institution, it can lead to further effects such as population growth and inequality. Then these things might be critical for the development of other large-scale technologies like those that we associate with the Industrial Revolution. Right, so the point is that technological feedback can certainly occur, but we have no reason to assume that it will always occur, that it will be indefinitely self-sustaining when it does, or that will lead to certain kinds of technologies rather than others. So the answers to questions like that will depend on a wide variety of particular conditions that may or may not apply. So this is a problem for figuring out sort of the general probability of extraterrestrial technologies and technosignatures. So I've painted a picture of technology as an enormously complex phenomenon spanning a scale from molecules to societies and beyond. Now, how are we supposed to deal with all of this? Because I'm not really sure, but I'd like to think that this vast scope isn't just a problem, it's also part of the solution. So interaction across multiple levels of spatiotemporal organization is a key feature of evolutionary thinking that can allow for synthesis of complex phenomena in terms of a smaller number of recurring relationships and processes. For example, I have stressed the importance of internal models for everything from motor planning to the development of theory of mind and the formation of social institutions. This has led us to suggest a perceptual-motor hypothesis for the construction of human technological cognition, starting with ancient primate perceptual-motor systems for body awareness and engagement with the world. So according to this perceptual-motor hypothesis, sensory motor acuity and experience shape the construction of the internal models and intuitive physics required for material production. In turn, these sensory predictions by these models also support the sense of agency and self-other discrimination that underpin human self-awareness, imitation, social cognition, and empathy. These socio-cognitive capacities enable technological collaboration and reproduction, and thus create possibilities for further biocultural evolutionary feedback. So in fact, in support of this sort of this perceptual motor model that I've got going on here, the frontoparietal systems that support action, execution, observation, and intuitive physical reasoning have in fact undergone major structural and functional changes over human evolution. These systems are also relatively early developing in the life course and directly engaged with the sensory periphery, which makes them a key nexus for interaction between externalizing processes of technological niche construction and internalizing processes of neurocognitive development. Okay, so what are the chances? Now, even assuming that this hypothesis that I've just presented you were eventually supported, I have no idea how particular it is to humans, our anatomy, physiology, evolutionary history, or how likely it would be for extraterrestrial life to follow a different path to similar outcomes. So I apologize for that. I'm sorry I don't have a better answer, but thank you very much for your attention, and I hope you found something useful in the talk.
Dietrich, thank you very much. That was a fascinating talk, and you covered a really broad range of topics and concepts. A lot for us to think about. We do have, let's see, one question from, I'm sorry, I might butcher this name, Mateusz Józefowicz. And it's a more general question. for you, Dietrich. It would be good to see it's good to see a fellow archaeologist presenting at this great event. Why, in your opinion, are there so few of the culture scholars in this area? How can we link more SETI astrobiological communities with our colleagues to transfer useful methodologies and perspectives? Have you thought about that very much?
Yeah, well, I suggest that you have Rob invite you to one of these conferences. That's how it happened for me. Obviously I hadn't been particularly thinking about the relevance of what I was doing to questions of extraterrestrial intelligence. So I think and I'm not aware of a lot of big movement within archaeology to become interested. So I think it would probably have to come from the other direction to let people know that that there's a perception that they have something to contribute to these debates. I do think that archaeologists, especially people who study human evolution, love to speculate about big questions, as I've just been doing. So I think you'd find a receptive audience. You might try to reach out to some of the cultural evolutionary theorists as well, who try to trade in very generalizable sorts of ideas and processes, and you probably get them to develop some models. So those would be my suggestion. I do think right now it seems that it's more likely to come from the SETI community to the archaeologists and anthropologists as opposed to the other way around. Although somehow, Rob, you somehow got involved in this. So I don't know, maybe you're better poised to answer the question.
Yeah, I gave a talk in the first conference last year on the evolution of human intelligence, which, it's difficult to say just how that might apply to the presence of extraterrestrial intelligence, just like the problem you had with the issue of technology. I will say, though, just to add that there have been anthropologists in general involved in this broad field, and it's been mainly, though, in the field of cultural anthropology. For cultural anthropologists have experience dealing with the other, and so they have spoken quite a bit about, well, how would we react if we did find an extraterrestrial other? So one of the purposes of this conference is to begin to define the various interdisciplinary links. And we are talking about what are still in many ways very disparate disciplines, but this is probably one of the biggest questions facing us, life elsewhere, and it will have probably the biggest consequences should we find it. So I think the broader the perspectives we have on the topic, the better. So Dietrich, thank you for adding to that. Let's see, Pierre Durand has a question for you, Dietz. Do you think there are cognitive costs, not social costs, to engaging with computer technologies or spending most of our days with computer-based technologies?
Yeah, as I say on Zoom here, I think there's quite a lot of interest in the impacts and effects of digital interaction. Everything from the concept of social media addiction to the way in which interacting with people online versus in person changes the sort of the effective feedback and your emotional engagement. And the issues of sort of multitasking and attentional issues as well. So people approach that sort of from health perspectives, and there's a lot of other people who are doing important work on that, who are experts in those sorts of things. I would just maybe add from my own perspective that any kind of technology is going to, particularly if you think of engagement with the world as an important part of what our cognition does. It changes your modes of engagement and alters the way we think about things. And whether we like that or not is kind of a value judgment. So, Plato was famously concerned about literacy, that it was going to destroy the mind. Basically by, people are no longer going to have to remember anything, and all of these very, a lot of intellectualism at the time was focused on developing your memory, because if you couldn't remember it, it was worthless, because, it's just gone. And it's true, right? I mean, it actually did destroy our memories. And probably computers are doing that even more now. But we think it's okay, or actually good. And now we value different things. So technologies, digital and otherwise, massively change human life. And that can impact things in ways we would say is, health, and other ways that are better described as culture change. And we want to be intentional about it because we do care. But 100 years down the line, people may have a different perspective on what happened now than we do. I'm not sure if that quite got to your question about exactly the cognitive impacts that you were thinking about.
Great, thanks. We have a question from Creon Levitt. How do you think your conclusions affect the last term of the Drake equation and its uncertainties? And I believe that last term has to do with the longevity of civilizations and the chance that they would coexist long enough to be able to communicate with one another.
Yeah, I probably don't have a lot to add on that hasn't been said better by others before. But from the perspective of the Paleolithic, right? One of the things that cultural evolutionary theorists, with their sort of the feedback, the runaway accumulation, have struggled with a little bit is just how stable things are in the Paleolithic. You've got these like hand axes, and they're made for 1 million years across much of the world, and it's sort of hard to square that with this idea that we have, these high fidelity learning and feedback, and the expectation is things would change more rapidly. But sort of the broader perspective that I was trying to present, suggests that that's maybe not surprising. Stability could be, quite natural and quite normal when you consider these sort of costs and benefits within the situation as it exists. And that sort of turns the question on its head, is like not why were things so stable in the Paleolithic, is why are they so unstable now? Why does everything change so fast? And I mean, the obvious answers have to do with, the numbers of people and the complexities of the technology and the complexities of the societies that create such a potential for recombination, and in basically an unstable system. As we know that certain network architectures can be very unstable, and it seems, at least technologically, we're in one. And I don't know if the only way to get to really complex, like world-altering technologies, is to go through and become such an unstable system. And if it is, then they're probably not going to last long, one way or another. Maybe it would be a good thing, sort of like eco-Eden in the future or something like that. But collapse, definitely a possibility. So I don't know.
Yeah.
Many other people have had that insight, but that's my take on it.
Harkening back to the positive effects of mass extinctions that Jonah Chouanier was talking about yesterday. We have a comment in the chat room. I believe
Jill has her hand up as well, Rob. Sorry.
Oh, okay. From David Grinspoon. In the absence of making a specific estimation of the probability of human style cognition, can you comment on whether or not you see any limiting evolutionary steps which would make such a development extremely rare or potentially unique?
No, that's interesting. Off the top of my head, I don't see why it would be. The cultural evolutionary perspective that I presented of the sort of the threshold suggested that there is this adaptive valley you have to cross, which would make it unlikely. I don't know exactly how unlikely. It would be hard to say, but that would be an argument that it would be sort of a uniquely difficult thing to do. But I think that that's based on an an assumption about the difference between social and individual learning that I don't think is sustained, that they require separate mechanisms. And so it was based on the cost of building new social learning machinery, in the brain, which was assumed to be costly. And if you recognize, as a lot of psychologists do, that in fact you have the same basic learning mechanisms either applied in a social setting or an individual setting, then that goes away. And so in fact you get rid of that fitness valley. I don't have an explanation for why only humans or have this sort of and why it's the Anthropocene, right? Why we are the only ones that have changed so much our impact on the biosphere. Whereas I think if you accept this idea of a threshold, it would have to be that entering this pathway is just really unlikely, like a 1 in a million thing or something like that. Whereas for me, I think we've got this bushy tree of different human species, hominid species. We've got this bushy tree of different technologies, and on one of them, we flip like heads 100 times in a row. But there were, sufficient range that was just going to happen. So probabilities, I don't know. I'm missing too many to actually. I don't see that it's uniquely difficult to evolve complex technologies, I guess would be the short answer.
Well, that's good news for many people in this conference. Sorry, Jill, I didn't see your hand up earlier. You have a question?
Yeah.
Jill,
for some reason, I can't type into my Q&A, so I keep raising my hand. As a paleoarchaeologist, you probably have more of an opportunity to assess whether Steven Pinker's claims by looking at old graveyards that we are now kinder and gentler than we've ever been. And that wraps into SETI because we end up always answering questions from the public about should we worry if they come here that they're going to eat us up. And I'm inclined, if Stephen is right, to think that cultural evolution will continue and produce something that is not so aggressive.
Yeah, and so the primary data for Pinker's claim, everything in archaeology is difficult. I mean, it is really hard to estimate mortality rates in the past and rates of violence. And so when people write these sort of very large survey books, there's always the problem that you'd have to go through, and that's not particularly my area. You'd have to go through like virtually every single claim that they make of evidence that supports this and evaluate the primary research. And when you do that, a lot of times you find that you have like 100 examples, each of which is 50% chance of being correct. And so like, what do you do with that? So I'm not sure about the specific data supporting Pinker's claim. I do think that in general, though, it's not so much about the proportion of the population that's killed by violence as the potential to basically kill everybody all at once, which we now have and never did. And it only takes one of those. So what are the probabilities of that? And also I think the question of survivability may not be so much about intentionally killing each other as unintentionally killing ourselves off. So I don't really know. And even if it were the case in humans, I could easily see that there were a different pathway on another planet and a different scenario. I think it would tend to be contingent on how you got there. So I presented a view of technology and humans as being very reliant upon collaboration and cooperation. If there's another way to solve these problems, then you might not have that kind of important selection for pro-social behavior that we've had in humans. And I don't know what a species would look like in that case. I guess like I said, I find a lot of these things to be very imponderable. I'm even wrestling to understand the past of humans and trying to figure out what might have happened with another species. But yeah, I'm not sure that Pinker exactly sealed the deal with the book either.